Hello and welcome back to Engineers Olympiad. We're doing the numerical questions for the topic weight volume relationships in geotechnical engineering. We have uploaded many videos before this video. You can watch those videos before watching this video. Precisely, this is the video lecture number 5 on the same series. Four video lectures have been already uploaded on the channel Engineers Olympiad. You can watch those videos before watching this video. So let's get started. Question is, a sample of a sample of wet silty clay soil has a mass of 126 kilograms. The following data were obtained from laboratory tests on the sample. Wet density has been found equivalent to 2.1 grams per cc. Specific gravity of soil solids we have to take as 2.7, and the water content is 15%. We have to determine the dry density, porosity, void ratio, and degree of saturation. So let's get started. All right. Bulk density has been given in the question, 2.1 grams per cc, and the water content has already been determined by the laboratory test on this sample of clay, which is wet silty clay soil, and that was found to be 15%. All right. I have to find the dry density first. I can very easily use equation dry density is equal to bulk density 1 plus water content, and I'll be having my dry density. So dry density in this case is equal to bulk density, which is equivalent to 2.1 grams per cc, divided by 1 plus water content, which is 15%. That is 0.15. So by calculations, my dry density is equal to how much? It is 1.826 grams per cc. So the first part of the question is completed. The first parameter that question demanded to find the answer for, that was dry density, that has been found equivalent to 1.826 grams per cc. Moving forward, we have to find the porosity. For that, I'll be finding the void ratio first. And how I'll be arriving at my void ratio? Listen carefully. We also know that dry density is equal to, if I use the generalized formula, G density of water 1 plus E. Since I have already calculated this, so it will go here, 1.826. Specific gravity of soil solids we have to use as 2.7 as given in the data. 2.7. Density of water is 1 gram per cc divided by 1 plus E. So 1 plus E is equal to 1.47 as per the calculation. So E is equal to 0.47. So void ratio we have also calculated, and it came equivalent to how much? 0.47. Now I can very easily find the porosity. Why? Because I know the equation correlating porosity with void ratio, which is N is equal to porosity is equal to E divided by 1 plus E. So E is 0.47 divided by 1 plus E is 1.47. By calculations, porosity is equal to 31.9%, which is approximately equal to 32%. Also done. Porosity is done, void ratio is done, dry density is done. The already calculated factor was this bulk density, which was this data was obtained from the laboratory tests as were conducted on this wet silty clay sample of soil whose mass is 126 kilograms. Now the last thing that needs to be found is the degree of saturation. Degree of saturation denoted by S is a ratio between volume of water to the volume of voids. All right. Degree of saturation is a ratio of volume of water to the volume of voids, and we know that degree of saturation is generally expressed as a percentage, and it is equal to 0 when the soil is absolutely dry, and it's equal to 100% when the soil is fully saturated. In expressions, we use this as a decimal, but we generally express it in terms of a percentage. All right, but here in this question we don't know the volume of water, neither do we know the volume of voids, so we'll be using alternate equation to arrive at degree of saturation, that is Es is equal to Wg. All right, so S is equal to Wg divided by E. We know water content, that is how much? 15%. We know G, that is to be used as 2.7, and void ratio we have calculated as 0.47. So by calculations, my degree of saturation is equal to 86.17%. With this, we have completed the question in all respects. We have found dry density, porosity, void ratio, and degree of saturation as well. All right, moving on to the next question. Question is, the moisture content of an undisturbed sample of clay belonging to a volcanic region is 265%. Under 100% saturation, the specific gravity of solids is 2.5. The dry unit weight is 3.3 kilonewton per cubic meter. Determine the saturated unit weight, the submerged unit weight, and the void ratio. All right, so let's get started and solve this question. This is a question where in data the sample of an undisturbed clay which belongs to a volcanic region has been taken and the moisture content was found to be 265%, which is very high. That is why it says it is under 100% saturation. That means all the voids only contain water and there is no air phase. Alright, so in the system it has become a two-phase system rather than the usual three-phase soil system. And the specific gravity is this, dry unit weight is this. We have to find the saturated, submerged unit weight, saturated and the submerged unit weight. Moreover, we have also to find the void ratio. Alright, so let's get started. See, I know the equation dry density or dry unit weight rather. Dry unit weight is equal to bulk unit weight 1 plus water content. Dry unit weight has been given how much? 3.3 kilonewton per cubic meter. Bulk divided by 1 plus water content. Very high water content, 265%. So here it will become 2.65. We also report water content. We generally express it in terms of percentage, but in computations we use it as a decimal. All right, so by calculations, bulk density is equal to 12.045 kilonewton per cubic meter. This is the bulk density, bulk unit weight rather. Bulk unit weight is 12.045 kilonewton per cubic meter. But see the question once again. It says this sample of clay which is undisturbed and which belongs to a volcanic region, it is under 100% saturation. If it is under 100% saturation, that I can very confidently say that the saturated unit weight is equal to bulk unit weight. All right, because in this case this clay is under 100% saturation, so bulk unit weight is equal to saturated unit weight. We have found the bulk unit weight, so saturated unit weight is also same. It is 12.045 kilonewton per cubic meter. All right, so we have completed the first thing that the question demanded to find, was to determine the saturated unit weight, which is equal to bulk unit weight and which is equal to 12.045 kilonewton per cubic meter. All right, the next thing that we need to find is the submerged unit weight and the void ratio. So let's find the submerged unit weight first. We know submerged unit weight is saturated unit weight minus unit weight of water. So submerged unit weight is saturated 12.045 minus unit weight of water 10 kilonewton per cubic meter. So this is equal to how much? It is equal to 11.045. Sorry, it is 2.045. I thought this is 1. Sorry. So this is 2.045 kilonewton per cubic meter. So submerged unit weight has been calculated as well and it's equal to 2.045 kilonewton per cubic meter. The last thing that we need to find is the void ratio. See how I'll be calculating void ratio. I know the dry unit weight. Alternate equation is G gamma W 1 plus C. Dry unit weight was given in the question itself, 3.3 kilonewton per cubic meter. So it is 3.3 kilonewton per cubic meter, G 2.5, unit weight of water 10, 1 plus E, right? So 1 plus E by calculations is equal to 7.57. So the E is equal to 6.57. Very high void ratio. All right, void ratio is very high. Moisture content is also very high. Clay is under 100% saturation, and it is an undisturbed sample of clay which belongs to a volcanic region. So we have completed question in all respects. We have found the saturated unit weight, submerged unit weight, as well as the weight ratio. All right, moving on to the next one. Next question is, a sample of saturated clay from a consolidometer test has a total mass of 1.526 kgs and a dry mass of 1.056 kgs. All right. The specific gravity of the solid particles is 2.7. For this sample, we have to determine the water content, the weight ratio, the porosity, and total density. All right. So let's find this. All right. So let's solve. A sample of saturated clay from a consolidometer test has a total mass of this and the dry mass of this. The specific gravity is this much. We have to determine the water content, weight ratio, porosity, and total density. Let's find the water content first. Water content is equal to consolidometer test. Water content is total mass before drying 1.526 minus dry mass 1.053 divided by 1.053. By calculations, water content is equal to 44.9%. All right. Void ratio is equal to Wg by S. So void ratio is equal to water content is how much? 44.9%. G we have been asked to use 2.7. So here it's 2.7. And S, what is S? A sample of saturated clay, so S is equal to 1. All right. So E by calculations, this is 1. 0.449 into 2.7 divided by 1. So by calculations, this void ratio is equal to 1.212. All right. So we have calculated water content. We have calculated void ratio. Next two things that need to be found are the porosity and total density. So porosity. When we know the void ratio, we can very easily find the porosity. Porosity is equal to E divided by 1 plus E. All right. So porosity is E is how much? 1.212. So it's 1.212 divided by 2.212. By calculations, it is 54.79%. The last thing that needs to be found out is the total density or the bulk density. So the total density by generalized equation is G plus SE gamma water 1 plus E. So the total density is G is 2 point how much? 7 over here. 2.7. S, it's saturated clay, it's 1. All right. E 1.212. Density of water how much? 1 gram per cc divided by 1 plus E 1.212 is the void ratio. Yeah. So by calculations, total density or bulk density is equal to 1.768 grams per cc. All right. So this is how we calculated every parameter that question asked us to find. Water content done, void ratio done, porosity done, and total density as well. Moving on to the next one. Next question is, a sample of silty clay has a volume of this much and a mass of this much. A dry mass of this much and a specific gravity of solids is 2.7. We have to determine the void ratio and degree of saturation. So let's solve this question. All right. So what data has been given? Volume 14.88 cc, total mass 28.81 grams, and the dry mass, that is mass of soil solids, is how much? It is 24.83 grams. We have to determine the void ratio and the degree of saturation. Let's find the volume of soil solids first, which is given by equation ms divided by g and density of water. So volume of soil solids is mass of solids, that is 24.83, divided by g, we have been asked to use as 2.7, and density of water is 1 gram per cc. So by calculation, the volume of soil solids is 9.2 cc. Alright, 9.2 cc. Volume of voids, total volume minus volume of solids. Volume of voids is, total volume is how much? 14.88 cc. So it is 14.88 cubic centimeters minus this much, 9.2 cubic centimeters. So volume of voids is equal to 5.68 cc. So we have total volume, we have volume of voids, and we have volume of solids as well. Alright. Volume of solids came equivalent to 9.2 cc and volume of voids is 5.68 cc. Let's try to find water content as well, because we know the mass before drying and after drying. So water content is W first, 28.81, 28.81 minus mass after drying, that is how much? Dry mass is 24.83 grams, minus 24.83 divided by 24.83. By calculations, water content is equal to how much? It is equal to 16%. Alright, water content is equal to 16%. Now I can find, what do we need to find? We need to find void ratio and degree of saturation. So void ratio, as we know, void ratio is equal to volume of voids divided by volume of solids. We know volume of voids 5.68 cc. We know volume of solids 9.2 cc. So 9.2 over here. So by calculations, void ratio is equal to 0.617. So we have calculated the void ratio. The next thing that we need to find is the degree of saturation. We know we can use, we know the degree of saturation is volume of water divided by volume of this voids. Since we know volume of voids but we don't know volume of water, so I'll be using the alternate equation. ES is equal to WG. So S is equal to WG divided by E. Water content is how much? We have found it to be equivalent to 16%. So 0.16. G 2.7. Void ratio we just calculated 0.617. So by calculation, degree of saturation is 70%. So we have calculated both void ratio as well as the degree of saturation, and with this we have completed the question in our respects. Moving on to the next question. All right. So the next question is this one. All right. A soil sample in its natural state has a mass of 2.29 kgs and a volume of this much. All right. Under an on-dried state, the dry mass of the sample is this much. The specific gravity of solids is 2.68. Determine the total density, water content, void ratio, porosity, and degree of saturation, and the air void ratio as well. Alright, so this is quite a lengthy question, but let's solve this. Alright, what data has been given? A soil sample in its natural state has a mass of this much and a volume of this much. So first I'll find the bulk density. Bulk density is mass per unit volume. Mass is how much? In natural state, it is 2.29 kgs. 2.29 divided by volume. Volume is 1.15 into 10 raised power minus 3. 1.15 into 10 raised power minus 3 cubic meter. Yeah, cubic meter. So by calculation, bulk density is 1991.30 kgs per cubic meter. This thing was in kg, this was in cubic meter. Alright, so I have calculated the bulk density, which is 1991.30 kgs per cubic meter. Next, let's find the water content. Water content is equal to, see, under an own dried state, the dry mass of the sample was this much. In natural state, it was this much. So I can very easily find the water content. Water content will be 2.29 minus this. 2.29 minus 2.035 divided by 2.035. So by calculations, water content is equal to 12.5%. All right, 12.5%. Now I'll be finding the value of volume of solids. Volume of solids, as you know, it's ms divided by g, density of water. So volume of solids is equal to mass of solids is how much? This much. The dry mass of the sample is 2.035 kgs, that is mass of solids, soil solids, that is 2.035 kgs divided by g, we have to use as 2.68. All right, 2.68 multiplied by density of water, it's 1 gram per cc. So volume of soil solids or solids is equal to how much? 759.32 cc or cubic centimeters. All right, now I can find volume of voids, because we know that volume of voids is total volume minus volume of solids. So volume of voids is total volume is how much? It is 1150 cc's, because actually it was 1.15 into 10 raised power minus 3, but cubic meters. So this is equal to 1150 cc or cubic centimeter minus volume of solids is 759.32. So by calculations, volume of voids is 390.68 cc or cubic centimeters. All right, now we can very easily find void ratio. How? Because it's a ratio between volume of voids to volume of solids. We know both of them, we can find void ratio. Void ratio is equal to volume of voids, which is 390.68, divided by volume of solids, 759.32. 759.32. So by calculations, it is equal to 0.51. When I know the void ratio, I can find the porosity. Porosity is equal to E divided by 1 plus E. So E is 0.51 divided by 1.51. It is equal to 33.7%. What else do we need to find? Total density, that is the bulk density, done, this much. Water content, this much. Void ratio, this much. Porosity, this much. The only thing that remains is there are two things, degree of saturation and air void ratio. Let's find the degree of saturation first. Degree of saturation, S Wg divided by E. Water content, 12.5%. 12.5% multiplied by G, that is 2.68. Void ratio, 0.51. So by calculation, degree of saturation is equal to 65.6%. All right. The last thing that we need to find is this air void ratio. All right. Air void ratio air void ratio is equal to porosity multiplied by 1 minus degree of saturation. Alright, so air void ratio is porosity is how much? 33.7%. 33.7% multiplied by 1 minus degree of saturation is how much? 65.6. By calculations, air void ratio is equal to 11.59%. This is the air void ratio, which was equivalent to porosity multiplied by 1 minus degree of saturation, and which came equivalent to how much? 11.59% is our air void ratio. Alright, so we have completed the question in all respects. Moving on to the next one. Next question is, a soil sample has a total unit weight of 16.97 kilonewton per cubic meter and a void ratio of 0.84. The specific gravity of the soil particles is 2.70. Determine the moisture content, the dry unit weight, and the degree of saturation of this sample. Alright, so let's solve. What data has been provided? Total unit weight, that means the bulk unit weight, 16.97 kilonewton per cubic meter. Void ratio 0.84 and specific gravity is 2.70. We have to find the moisture content or the water content, the dry unit weight, and the degree of saturation. Let's first use a generalized equation for the total unit weight or the bulk unit weight, that is G plus SE unit weight of water 1 plus E. So this is equal to how much? G is 2.70 plus S as it is E 0.84. Unit weight of water 10 kilonewton per cubic meter divided by 1 plus E. E is 0.84. This will become 2.70 plus 0.84 S multiplied by 10 divided by 1.84. Alright. By calculations, this S is equal to 50.23%. This is the S. Can you tell me how? Because I use this as 16.97 over here. So in this equation, this becomes 16.97 is equal to 2.70 plus 0.84 S multiplied by 10 divided by 1.84. After solving this thing, we arrived at degree of saturation, which is equal to 50.23%, because the total unit weight or the bulk unit weight was itself provided in the question, which was 16.97 kilonewton per cubic meter. I used the generalized equation and I arrived at the degree of saturation, which came equivalent to how much? 50.23%. The next thing that we need to find is degree of saturation and dry unit weight. Let's find the dry unit weight first. Dry unit weight, as you know, is bulk unit weight divided by 1 plus E if I'll be using this equation. Alright, so the bulk unit weight, the dry unit weight is equal to G 2.70 unit weight of water 10 kilonewton per cubic meter 1 plus E. E is how much? 0.84 over here, 0.84. So by calculations, dry unit weight is 14.67. It is 14.67 kilonewton per cubic meter. This is the dry unit weight. Then we can find the water content. ES is equal to WG, generalized equation. So water content is ES by G. So water content is equal to E 0.84, degree of saturation 50.23%, G 2.70. So water content will be 15.62%. All right, 15.62%. So we have calculated each and every thing that the question demanded us to find. We have found the moisture content, which is 15.62%, the dry unit weight, which is 14.67 kilonewton per cubic meter, the degree of saturation of the sample, which is 50.23%. So we have calculated the question. We have calculated each and everything, and we have completed the question in all respects. So let's move on to the next one. Next question is, a soil sample in its natural state has, when fully saturated, a water content of 32.5%. Determine the void ratio, dry and total unit weights. Calculate the total weight of water required to saturate a soil mass of volume 10 cubic meters. Assume G equal to 2.69. Alright, so let's solve this. What data has been provided? We have been provided a water content which is equal to how much? 32.5%. G, we have to use 2.69. And the soil sample in its natural state is fully saturated. That means S is equal to 1. Let's find the void ratio first using the generalized equation of ES is equal to WG. So E is equal to WG by S. Water content 32.5%. G is 2.69 and degree of saturation is 1, because it's written that the soil sample in its natural state when fully saturated. So it's fully saturated, S is 1. So by calculations, void ratio is equal to how much? 0.874. 0.874 is the void ratio. What else do we need to find? Determine the void ratio, dry and total unit weight. So dry and total unit weight. Total unit weight is the bulk unit weight, which is equal to G plus SE, unit weight of water 1 plus E. So total unit weight or the bulk unit weight is G is 2.69, S is 1, and E is 0.874. We just calculated it. 0.874. 0.874 divided by 1 plus E, that means 1.874, and here we have to multiply it with the density or the unit weight of the water, that is 10 kilonewton per cubic meter. By calculations, the total unit weight or the bulk unit weight is equal to 19.01 kilonewton per cubic meter. We have to also find the dry unit weight. Dry unit weight is the total unit weight or the bulk unit weight divided by 1 plus water content. So dry unit weight is equal to bulk unit weight, which we just found out, which is equivalent to 19.01 divided by 1 plus water content. Water content is how much? Water content, as given in the question, is 32.5%. 32.5%. By calculations, dry unit weight is equal to 14.34 kilonewton per cubic meter. We have completed the part A of this question, wherein we were asked to find the void ratio, which we calculated, dry and the total unit weight. The next part, or the part B of the question, says calculate the total weight of water required to saturate a soil mass of volume 10 cubic meter. Alright, now we have to find this much. We know the dry unit weight, we just calculated it. It is equal to 14.34 kilonewton per cubic meter. Can't we write it like that? Alright, this dry unit weight will be definitely equal to weight of the soil divided by total volume. So this is equal to 14.3 kilonewton per cubic meter. Can I write this is equal to 14.3 multiplied by V? We have been given Calculate the total weight of water required to saturate a soil mass of volume 10 cubic meters. 10. So it is 14.3 multiplied by 10 cubic meter. This is kilonewton per cubic meter. So by calculations, weight of solids is equal to 143.00 kilonewton. Alright, so this is the weight of the soil solids. How much? 143.0 kilonewtons. Now I know the bulk unit weight as well. Alright. Bulk unit weight was equal to how much? 19.01 kilonewton per cubic meter. 19.01 kilonewton per cubic meter. Can't I write it like this? It is total weight divided by volume. That means total weight is equal to 19.01. Volume is 10. Alright. So total weight is equal to 190.1 kilonewton. This is the total weight. Alright. So the weight of water required is total weight minus weight of solids. So the weight of the water will be how much? Total weight is 190.1 kilonewton minus weight of solids is 143 kilonewtons. 143. So weight of water is 47.1 kilonewton. This is how we solve these type of questions. Alright, calculate the total weight of water required to saturate a soil mass of volume 10 cubic meter. The total weight of water which is required to saturate a soil mass of volume 10 cubic meter is 47.1 kilonewton. Alright, moving on to the next question. Next question is, a soil mass in its natural state is partially saturated, having a water content of 17.5% and a void ratio of 0.87. Determine the degree of saturation, total unit weight, and dry unit weight. What is the weight of water required to make a mass of 10 cubic meter volume to get saturated? We have to assume G as this much. So this question also has two parts. Let's solve it.